Hello friends, in last lecture we solved two questions from exercise 4.1. In first question we find the joint equation from separate equations, and in second question we find separate equations from the combined equation. So today we solve problem third and next questions. Now see the next question. Find the combined equation of pair of lines passing through the origin and perpendicular to the lines represented by following equations. So the first equation is 5x square minus 8xy plus 3y square equals to 0. We can solve this equation by two methods. By separating the equations or by comparing with ax square plus twice hxy plus by square equals to 0. From that also we can find the combined equation of pair of lines passing through the origin and perpendicular to lines represented by these equations. So by first method, compare the equation 5x square minus 8xy plus 3y square equals to 0 with homogeneous second degree equation ax square plus twice hxy plus by square equals to 0. After comparing, here value of a is 5, so we write a equals to 5. Here value of twice h, that is the coefficient of xy, is minus 8, so we write twice h equals to minus 8 and b equals to 3. So we get value a twice h b after comparing given equation with this homogeneous equation, second degree homogeneous equation. Now suppose m1 and m2 be the slope of the lines represented by 5x square minus 8xy plus 3y square equals to 0. So this is combined equation. So we consider here slope of that two lines is m1 and m2. We know the sum of the slopes and product of the slopes value in terms of h and ab. So we write here m1 plus m2 equals to minus twice h by b, and value of twice h is minus 8 here. So we substitute value of twice h as minus 8. So after substituting value minus get plus, and value of b is 3. So we get the value of m1 plus m2 8 by 3. Now product is a by b. So the value of a is 5, value of b is 3. So we get m1 into m2 equals to 5 by 3. We denote it by equation number 1. Now we have to find the lines which are perpendicular to these lines. The slope of lines are m1 and m2. We have to find the combined equation of lines which are perpendicular to these lines. So their slope must be in a reciprocal form and their sign must be opposite. So the slope of first line, here slope of given line is m1. So the line perpendicular to it has a slope minus 1 upon m1, and line perpendicular to line having slope m2 is minus 1 upon m2. So using these slopes as a slope of required lines, we write. Now required lines are perpendicular to these lines, therefore their slopes are minus 1 upon m1 and minus 1 upon m2. Since these lines are passing through the origin, their separate equations are. In question, we have to find equations of line passing through the origin. So we know the form y equals to mx. In y equals to mx, constant term c is absent because that line passing through the origin. So for first line, we substitute the slope minus 1 upon m1. So the equation of first line is y equals to minus 1 upon m1 into x, and y equals to minus 1 upon m2 into x. So after cross multiplying, we get m1 into y is equals to minus x and m2 into y equals to minus x. So after transferring this minus x to left hand side, we get x plus m1y equals to 0 and x plus m2y equals to 0. These are the equation of lines passing through the origin having slope minus 1 upon m1 and minus 1 upon m2. Now we have to find their combined equation. Therefore their combined equation is, we have to multiply these two terms. So we write here x plus m1 into y into x plus m2 into y equals to 0. So multiply these two terms. So we write here x square plus m1 into m2 xy plus m1 into m2 y square equals to 0. So substitute the value of m1 plus m2 that we already calculate in equation number 1. So we write here by 1 m1 plus m2 equals to 8 by 3 and m1 into m2 equals to 5 by 3. Therefore after multiplying each term by 3 we get 3x square plus 8xy plus 5y square equals to 0. This is the required combined equation. Now we solve this example by this second method. So for that we have to reduce that second degree equation in the form of quadratic equation. So we divide each term by this equation by x square. So we rearrange this first. So we write 3y square minus 8xy and this 5x square at third position. So divide each term by x square. So after dividing by x square we get y square upon x square. Here also we divide x square and last term to x square. So here we write this y square upon x square in one square as y by x 8 square. And now here we can cancel x square with this x, one term of this x square with this x. So we get here y by x. Now here x square get cancelled. Now this is quadratic equation in terms of y by x. So by using the quadratic formula we can write y by x is equals to minus b. Here value of b is minus 8, so we write here minus of minus 8 plus or minus under root b square. So we write here square of b, that is minus 8 square minus 4 into a, value of a is 3, value of c is 5 and upon twice a, value of a is 3. So after calculating minus minus get plus, square of minus 8 is plus 64. So after multiplying this, 4 3s are 12, 12 5s are 60. So we get 64 minus 60, that is 4. So the square root of 4 is 2. Therefore y upon x is equals to, first we take plus sign, then we take minus sign. So y by x is equal to 8 plus 2 by 6. Therefore y is equal to 8 plus 2 10, 10 by 6, that is y equals to 5 by 3x. This is first equation. And for second equation we take minus sign. 8 minus 2, that is 6, 6 upon 6. So we get here y equals to x. This is first equation, this is second equation. Now we find the slope of these lines. So the first line slope is m1 equals to 5 by 3 and second line slope is m2 equals to 1. Now we have to find the slope of that lines which are perpendicular to these lines and passing through the origin. Therefore slope of first line is, we have to take the reciprocal of 5 by 3 is 3 by 5 and we have to change its sign. Sign is plus here, so we have to write sign minus. Now the slope of second line is 1, we have to take its reciprocal of 1 is 1 upon 1, that is 1, we have to change its sign. So we get slope for the lines which are perpendicular to these two given lines. Therefore equation of required lines are, since the lines pass through the origin, we use the form y equals to mx. So substitute m as minus 3 by 5 for the first line and m as minus 1 for the second line. So after multiplying by 5, we get 5y equals to minus 3x, and after transferring this minus x to left hand side, we get x plus y equals to 0. Therefore, then again shift this minus 3x to left hand side. These are the two lines pass through the origin. Now we have to find their joint equation. Therefore combined equation is, so we have to multiply these two equations, 3x plus 5y with x plus y. So 3x into x we get 3x square, 3x into y that is 3xy, 5y into x we get 5xy 5y into y, we get 5y square. Now add these two terms, 3xy plus 5xy, that is 8xy. This is a required combined equation. Now you can check by first method and second method, we get the answer same. Now see the second example. This example we solve by factorization method. So we separate this combined equation first and find the slope of separate lines. So for that we have to multiply 5 with minus 3. So 5 into minus 3, which is equal to minus 15. So we factorize this minus 15 so as to get the sum as plus 2. So 5, 3 are the factors, we require plus 2. So plus 5 minus 3, we take factor 5 and minus 3. So we write this middle term in the form of 5 and minus 3. Therefore 5x square plus 5xy minus 3xy minus 3y square equal to 0. Now take 5x common from first two terms. Therefore 5x in bracket x plus y, take minus 3y common from last two terms, we get x plus y is equal to 0. Now taking x plus y common, therefore x plus y in bracket 5x minus 3y is equal to 0. Therefore we write x plus y equals to 0 and 5x minus 3y equals to 0. So we have to find the slope of the line. So we write it in the form y equals to mx. Therefore y is equal to minus x and here we write 3y is equal to 5x. That is y is equal to 5 by 3x. Here y is equal to minus 1 into x. So comparing this equation with y equals to mx, we get slope of first line. Slope of first line, that is m1, is equals to minus 1. Slope of second line, that is m2, is equals to 5 by 3. Now these are the slopes of these lines. Now we have to find the slope of line which are perpendicular to these two lines. Therefore slope of lines perpendicular to given lines are, so the reciprocal of minus 1 is 1 upon minus 1, we have to change its sign. So the slope of first line is 1 and slope of second line, reciprocal of 5 by 3 is 3 by 5, we have to change its sign. So we write here 3 by 5 and we change its sign, that is minus 3 by 5. Now these are the slope of required lines. So first we find the required lines, then find their joint equation. Therefore equation of required lines pass through origin is, we know the form y equals to mx. So we substitute the value of m as 1 for first equation. Therefore y is equals to 1 into x, that is x minus y equals to 0. This is first line equation. And y is equals to, in place of m we substitute minus 3 by 5. That is, after cross multiplying we get 5y equals to minus 3x. So we write here 3x plus 5y equals to 0. This is equation of lines which are perpendicular to the lines which containing these combined equations. So we find the joint equation from these two equations. Therefore a required combined equation is x minus y into 3x plus 5y is equal to 0. Now we have to multiply these two brackets. Therefore we write x into 3x, that is 3x square, x into 5, so we get 5xy, minus y into 3x, that is minus 3xy, plus minus minus 5y square equals to 0. Therefore 3x square, so add these two terms, 5x minus 3xy, so we get 2xy minus 5y square equals to 0. This is the required equation. So in this way also we can find the equation. So see the third example, xy plus y square equals to 0. Now we have to find its separate equation first. So taking y common, we write y in bracket x plus y equals to 0. Therefore separate equations of the lines are y equals to 0 and x plus y equals to 0. So we find its slope first. Let m1 and m2 be the slope of these lines. So from this we find the slope of first line. We write this as y equals to 0x. So the slope of first line is 0. And this equation can be written as y equals to minus x. Coefficient of x is minus 1. So we write here slope of second line as minus 1. Now required lines are perpendicular to these lines. Therefore their slopes are, we have to take its reciprocal. So 0 can be written as 0 upon 1. So its reciprocal is 1 by 0. We know that 1 upon 0, that is slope not defined. And we know that slope of y-axis is not defined. So the first line must be y-axis, and we know that equation of y-axis is x is equals to 0. Therefore their slopes are minus 1 by m1 and minus 1 by m2. These are the slopes of lines which are perpendicular to these two lines. Also m2 is equals to minus 1. So from this we write m1 equals to 0, that means minus 1 upon m1, m1 is 0, so 1 upon 0, that is value does not exist. Also m2 equals to minus 1, minus 1 upon m2 equals to 1. Since these are the lines passing through the origin, their separate equations are, why we write here x equals to 0? Because slope of y-axis is 0. Slope of line perpendicular to x-axis, that is y-axis, is 0. So we write equation of y-axis as x equals to 0, and from the second slope we write here slope is 1, y equals to 1 into x, that is y equals to x. We write this as x minus y equals to 0. Therefore their combined equation is x into x minus y equals to 0. Therefore x square minus xy equals to 0 is the required combined equation. So the answer for third you can write in this way also. We take here y common, so we write here x plus y equals to 0. Therefore y equals to 0 and x plus y equals to 0. So this is equation of x-axis. We already discussed all these parts in first lecture. We know that equation of x-axis is y equals to 0. So the line perpendicular to this y-axis is y-axis, and we know that the equation of y-axis is x equals to 0, because we required a line perpendicular to these two lines. So perpendicular to x-axis is y-axis. So we get directly equation of line perpendicular to this line y equals to 0 is x equals to 0, and we find the slope of this second line. Slope of x plus y equals to 0. So for that we write y equals to minus x. Therefore slope is equals to minus 1. Therefore slope of line perpendicular to it is, so we have to take reciprocal of minus 1. So minus 1 upon 1 we have to change its sign. So we get their sign after changing as +1. So here slope of line perpendicular to this line is 1. Therefore, equation of line having slope 1 is y is equals to 1 into x, that is x minus y equals to 0. So we directly get a line perpendicular to this x-axis is y-axis, whose equation is x equals to 0, and another line x minus y equals to 0. Therefore, combined equation of line x into x minus y equals to 0, that is x into x square minus xy to 0. This is the required combined equation. Now see the next example. 3x square minus 4xy equals to 0. So after taking x common, x in bracket 3x minus 4y equals to 0. Therefore x equals to 0 and 3x minus 4y equals to 0 are the separate equations. So x equals to 0 is the equation of y-axis. X equals to 0 is the equation of y-axis. So slope of y-axis does not exist. So for that, we have to find the slope of x-axis. Slope of x-axis. X-axis has angle 0 with itself. So the slope of x-axis, that is equation of x-axis, is y equals to 0, because we required a line perpendicular to this y-axis, and we know that line perpendicular to y-axis is x-axis, and it also passed through the origin. So we directly write line perpendicular to this x equals to 0, that is for y-axis is x-axis. So the equation of line perpendicular to this x equals to 0 line is y equals to 0. Now we have to find the line perpendicular to this line 3x minus 4y equals to 0. So first we find the slope of line 3x minus 4y equals to 0. Therefore, slope of line for y equals to 3x, that is y is equals to 3 by 4 is. Now after comparing this y equals to 3 by 4 x with y equals to mx, we get slope of this line is 3 by 4. Now we have to find this slope of line which is perpendicular to this line. Therefore, slope of line perpendicular to given line is. Now we have to take its reciprocal. So reciprocal is 3 by 4. We have to change its sign. So we get here minus 4 by 3. Now this is the slope of line which is perpendicular to this line. So we find the equation of line passing through the origin. Therefore, required equation of line having slope minus 4 by 3 and passing through origin. Passing through origin. Therefore, y is equals to mx. So in place of m we replace minus 4 by 3 into x. So after cross multiplying this, we get 3y is equals to minus 4x, that is 4x plus 3y is equals to 0. So this is second equation which is perpendicular to this line 3x minus 4y. Now line perpendicular to this y-axis is x-axis. So we get here equations y equals to 0 and 4x plus 3y equals to 0. Therefore, combined equation is, first equation is y. Second equation is 4x plus 3y equals to 0. Therefore 4xy plus 3y square equals to 0. That is 3y square plus 4xy equals to 0 is the required combined equation. Or you can write this in this way also. Consider 3x square minus 4xy equals to 0. So taking x common, we write x. 3x minus 4y equals to 0. Therefore separate equation of the lines are x equals to 0 and 3x minus 4y equals to 0. Let m1 and m2 be the slope of these lines. Then m1 does not exist because this x equals to 0 is the equation of y-axis. So the slope of y-axis does not exist. So we write here m1 does not exist, and m2 equals to slope of second line, which we calculate from the formula. Slope equals to minus a by b. Value of a is 3, value of b is minus 4. So here 3 upon minus 4 and minus sign get cancelled. We get here slope of this line is 3 by 4. Now required lines are perpendicular to these lines. So we write slopes are minus 1 upon m1 and second slope is m2. We write minus 1 upon m2 after substituting the value. So m1 does not exist, that means 1 upon infinity, any number upon infinity, that we get 0. Since m1 does not exist, minus 1 upon m1, so we get here 0. Also m2 equals to 3 by 4, so the slope of second line is minus 4 by 3, which we already seen in previous form also. Then m1 does not exist and m2 equals to 3 by 4. From this we calculate these two slopes. First slope is 0, second slope is minus 4 by 3. Now we know that slope is 0 when line is on x-axis or x-axis. Since these are lines passing through the origin, their separate equations are y equals to 0, because equation of x-axis y equals to 0, and second equation we calculate by y equals to mx. So for second slope we substitute the value minus 4 by 3. So after cross multiplying this we get equation 4x plus 3y equals to 0. Therefore their combined equation is y into 4x plus 3y equals to 0. That is 4xy plus 3y square equals to 0, or you can write 3y square plus 4xy equals to 0. In this way you can solve question number 3. Now see the question number 4. In this question number 4, we have to find value of k. The sum of the slopes of the lines represented by x square plus kxy minus 3y square equals to 0 is twice their product. In second example, the slope of the lines represented by 3x square plus kxy minus y square equals to 0 differ by 4. And in third, the slope of one of the lines given by kx square plus 4xy minus y square equals to 0 exceeds the slope of the other by 8. So we solve first question. So before solving this problem, we see what is meant by auxiliary equation. We know that the equation of line passing through the origin is y equals to mx. So from this we can calculate the value of m in terms of y and x, that is y by x is equals to m. So for the given equation we divide each term by x square. So we denote this as equation number 1. Divide each term by x square in equation 1. So after dividing by x square we get ax square upon x square plus twice hxy upon x square plus by square upon x square is equal to 0. So this last term we write b in bracket, b by x its bracket square. Here one x get cancelled with x in this x square, and this x square get cancelled with this x square. So we write first term as a, second term as twice y by x. Now we write this square term first. So we write this as y by x its square plus twice h y by x plus a square, sorry here value is a, is equals to 0. Now substitute the value of y by x as m. So we get here coefficient of y by x is b. So b m square plus twice hm plus a equals to 0. This is auxiliary equation. This is auxiliary equation. Now when you find auxiliary equation, substituting the value of slope, that is m, according to given condition, we get the condition for given line is perpendicular or parallel. So we find according to our problem condition. Now given line is 4x plus 5y equals to 0. This line coincides with one of the line for this combined equation. So we find the slope of this line. So slope of this line is m is equals to, that is minus a by b. Value of a is 4, value of b is 5. Now this is the slope of this line. Now this line coincides with one of the lines of this auxiliary equation. So slope of line coincide with given line is also minus 4 by 5. Therefore put m is equals to minus 4 by 5 in this auxiliary equation. So denote this as auxiliary equation by 2. Put m equals to minus 4 by 5 in equation 2. Therefore b m, value of m is minus 4 by 5 its square plus twice h m, value of m is minus 4 by 5 plus a equals to 0. Now after squaring, square of minus 4 is plus 16. So 16 by 25. Here plus minus 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 8h by 5 plus a equals to 0. Now we have to make base same for all these terms. So here base is 25. So we write this as 16b upon 25. To make base same, we have to multiply by 5 and divide by 5. So 8 5s are 40h upon 25 minus, plus multiply and divide by 25. So we get here 25a upon 25 is equal to 0. Now all the terms have base same, that is 25. So we write here 16b minus 40h plus 25a equals to 0. This is the required condition. In second example, we have given that this line 3x plus y equals to 0 is perpendicular with one of this line. So we have to write auxiliary equation for given equation first, that we see in first example. So we divide each term by x square, then substituting the values of y by x in this, we get bm square plus twice hm plus a equals to 0. If you have to write the direct equation, you have to write terms of y first. So bm square plus twice hm, after dividing x square by x square we get 1, so we write a. So you can write in second example the auxiliary equation directly. So the auxiliary equation for the equation ax square plus twice hxy plus by square equals to 0 is bm square plus twice hm plus a equals to 0. So we have to find the slope of given line. Given line is 3x plus y equals to 0. So slope of this line is minus a by b, that is minus 3 upon 1. So we get slope minus 3. Now this given line perpendicular with any one of this line. So slope of line here perpendicular with given line is, so the reciprocal of this is 1 upon minus 3. After changing sign we get plus 3, so we get here plus 1 by 3. Put m is equals to plus 1 by 3 in equation second, that is in auxiliary equation, because this is the root for this auxiliary equation, so this value must satisfy this equation. So we substitute value of b as 1 by 3, b into 1 by 3 its square plus twice hm. Value of b is 1 by 3 plus a equals to 0. Now we have to square first. Square of 1 is 1, square of 3 is 9. So we write b by 9 or b into 1 by 9 plus twice h by 3 plus a equals to 0. Now multiply and divide this second term by 3. Multiply and divide by 9. So this third term we get b by 9 plus, here after multiplying by 3 we get 6h by 9. 9a by 9 is equal to 0. Now here base is same. So taking base same, we write here b plus 6h plus 9a is equal to 0, because after transferring this 9 to right hand side, this is a required condition. So in this way we can find the conditions for the given equations. So we first write second degree homogeneous equation as ax square plus twice hxy plus by square equals to 0. If slope is m, so we write its auxiliary equation as bm square plus twice hm plus a equals to 0. So denote this as equation number 1. Now we have given that the line px plus qy equals to 0 is perpendicular with any one of the lines. So we have to find the slope of given line. Therefore from this slope is minus a by b. A is p here, so minus p by b. Value of b is q. This is slope for this line, and this line is perpendicular with one of the lines. So we have to find the slope of that one of the line. Therefore slope of line perpendicular to it is. Now we have to take its reciprocal. So reciprocal is q by p. We have to change the sign. Here sign is minus, so we have to write its sign as plus. So this is the slope, and this value must satisfy the equation number 1. So from equation 1 we substitute m is equals to here m is equals to q by p. So from equation 1 we write b in bracket, value of m is q by p. So write q by p its square plus twice m, value of m is q by p plus a equals to 0. So we write here b q square upon p square after squaring this first term plus twice h q by p, multiply and divide by p plus p square a upon p square, multiply and divide by p square. So we write bq square plus twice, here we write this as qp plus a p square upon p square is equal to 0. Therefore after transferring this p square to right hand side, bq square plus twice h pq plus ap square equals to 0. This is the condition that we have to show. So we have to rearrange for given equation is of the form ap square. So write this last term at first position and this first term at last position. We get same condition that given in our questions.